So we've covered all the areas that need to be covered with troubleshooting intermittent problems with the control head. Of course, an easy one to spot is if the trip line has crossed over some of these other suspension lines here. And if that's the case, if these have crossed over, then that may prevent the trip line from resetting inside the spring reel as well. It's normal, however, for when you finish dumping your load of water, sometimes the valve will be hanging out the bottom side of the bucket and it won't reset until it touches the water. And that's simply a matter of the fabric in the valve binding on itself and holding it up, providing enough resistance that the spring doesn't kick in until it touches the water surface, the water tension on the surface of the water, and then it relieves some of this tension and that allows it to reset and snap back in. But if this line is crossed over or these lines are crisscrossed, then that reset may not happen at all, and it's at that time you want to take a look at it and get the bucket down the ground and check it out for tangles here. So part of what we were showing earlier is pre-flighting the bucket. Again, you want to pull the trip line so you're simulating that there's a load of water in the bucket, and then when the pilot fires the solenoid, I'll move this by hand, when he fires the solenoid, that trip line will release. But you want to have constant tension on the water because this area here, this will be moving around in flight. When the bucket's full of water, this is what the bullet looks like. It's under constant tension. You can't go like this and expect to time it perfectly that you're going to give a true test of that solenoid. So you want constant tension on there. When the pilot sends the electrical signal down to open the solenoid, he'll get immediate feedback and he'll see that his switches are working correctly as well. So that's important in terms of pre-op flight testing, and then checking that all these lines are straight. And when your control head is sitting in this position, normally you would have the data plate and cover on the control head. Normally what's happening is it's opposite the bucket, because on the bucket end you have a weight, a ballast. On the front side of the bucket there's a ballast and weight, and that tends to roll to the bottom. So the front on the bucket right now is at the bottom, and the front up here is facing to the top. So what we're going to do, just to make sure we've got this oriented right, is we're going to flip it so that the front is facing down, and that now matches what we have on the bucket, and we can better assess whether these lines are oriented properly as well. You've got a instant deployment cable here, which is shorter than all the rest, but that is a very important cable. It can't be twisted around either. And you have your trip line over here at the control head. You've got your trip line coming out of the center here, and your IDS is moved over here. Your IDS deployment cable is moved over to this side, so it's away from the trip line, preventing these from crossing over. But you want to make sure that as you run through, that both of these lines are clear all the way to the hub. The trip line is connected to the hub right through that point there, and I'll get that suspension line out of the way. So there's your trip line, or sorry, your IDS deployment cable, and your trip line is here attached to all the purse strings. So those two are good. And next we want to check our suspension lines, and these are done in two sets of pairs on either side. The left-hand side of the control head goes to the left-hand side of the bucket, and the right-hand side of the control head, all those lines orient on the right-hand side of the bucket. So all we have to do is find the pair, and it's pretty simple to see which one is the front and which is the back, because they're oriented front and back like this. Again, the front is facing down right now, so here's our first suspension line and here's our second one, and we just put a finger in there and follow it all the way through right to the shell. And what you see here is that here's our front one and there's our second one, and this front one always goes to the chains where the ballast is, because that's the front of the bucket. The next one should connect to the next spot, and then the next pair in position 3 and 4 on the left-hand side of the bucket should also line up properly at the top end as well. And I'll keep that orientation here by keeping a finger between the lines. I prevent myself from losing track of which one is which. And there's the third position one, and the very back one. So these are fine. And on the right hand side, we'll find the same thing, that they're rotating around the rim of the bucket in sequence. That helps to distribute the weight of the water through all of the suspension lines. And if you crisscross these, you reverse the position, or you take, for example, this pair where the front line is going to the front of the bucket, but you take this back line and you put to the very back of the bucket, you've got a much wider angle between these two pairs, and you're putting more weight on that triangle. You've got a lot more weight because it's spread out more, and you're going to have less weight on this other pair, which will actually end up being a longer triangle, so there'll be less weight and tension on this. If this control head gets flipped through the lines, sometimes the only way, or the simplest way to sort out the tangle, is to undo these shoulder bolts here. These bolts can come off, and then the lines can be flipped over, or they can be turned 180 degrees to make sure that all the lines are oriented the right way. This is the easiest way to correct any tangles or anything with the suspension lines. You just simply want to be careful that you don't over tighten on this bolt or this nut here. There's a shoulder bolt under here, and sometimes there's a sleeve in here to keep these tabs from being squeezed in. If someone adds washers to this end, or sometimes they'll replace this bolt with a fully threaded bolt. Now you come along and you start tightening down on that nut, you're going to end up squeezing this shoulder boss in, and it'll crack right across here or here, and that base now is going to be garbage or scrap. Again, on our bucket shell here, we've got wear points on the shell, and I'll demonstrate how most people actually dry the buckets. A lot of people will stand them up in a teepee fashion so that the bucket's standing vertically. Any water that's collected in here between the shell and the valve is allowed to drip dry and to drip off the valve, because the valve tends to hang down when it's in this position. The valve is hanging straight down, and any water pockets that have collected in there are dripping through as well. The one hazard with doing it this way, or one thing to be aware of, I should say, is that the fabric tends to, when it gets hot and soft, it tends to bend over right at these points here, which is where the fiberglass ribs inside the shell stop right here, and this point along here tends to become an area where you can get some wear, and you'll see some of the white nylon material showing through those holes, and that's generally where you'll have small pinhole leaks of water coming through there. So you want to be aware of that, and try whenever you can, if you're letting it dry in this position, try to rework it, try to force it into a position where it starts to retain a shape where the orange material is as straight as possible. If you do have a shell that's older and it's got wear, and especially on the front edge where the ballast is, you'll find that as the buckets are pulled through creek beds, you'll have small little leaks along here. That's where our new AquaSeal glue comes in handy, and that is a urethane based glue. We've replaced the old repair glue, which was a Loctite 495, and that Loctite 495 is more like a crazy glue. It tends to leave a hard surface on the shell material, and it's more difficult to work with. This glue stays more flexible, it bonds really well with our fabrics, and if there are any holes on here, put on a good pair of gloves and actually clean it with isopropyl alcohol first, and then dab the glue onto your gloves and actually work it right into the spot where it needs sealing. And that will, because it's so difficult to patch here in this area, that will work really well to seal up the bottom area of your shell and give you a few more seasons out of it. So at the end of the day, you're going to need to close your bucket, and what I see people doing often is we're using a small bucket here, but what people will often do is they'll push on the IDS and try to push that in. And you'll see 2 or 3 people on a larger bucket. They'll be pushing on that IDS and struggling with it. Some people do this method where they hold the M-straps, put their foot on the hub and push it in, and that can work. If you've got some young guys and they're flexible enough, that method can work. But what I'd prefer is to take a set of 2x4s or a 4x4. You need at least 3 inches of height, and simply line it up with the hub. You need it to be as wide as the hub is, and you need that to be centered. You want to clear your cables out of the way, line it up with where that hub is going to come down, and go to the back end of the bucket and simply lift it. Make sure you're centered on those pieces of wood. Lift your bucket up, and as it rests with the bucket weight on that piece of wood, that IDS actually closes by itself. So you're finished for the day now. There's no need to struggle with pushing that IDS in. It's a nice, easier way of dealing with putting the bucket away.